So first of all, thanks everyone for attending today. Thanks also to Elizabeth for organising the series of presentations. I think these Tech and Talks are a really great opportunity for exploring topics that might not be part of the core curriculum at Launch School, but are still really interesting and useful. So my name's Carl. I'm going to be presenting today on debugging with Pry. So it's going to be mostly kind of presentation and demonstration. There may be some time for Q&A at the end. I'm not sure how much time we'll have left. But if you want to put some questions in the Q&A box, and if we have time, I'll try and get to them. Okay, so let's make a start. Some of you may know that I'm a TA here at Launch School, as well as being a student. And in my role as a TA, I carry out some of the 109 assessment interviews. And one thing I've noticed during the interviews that I've conducted is that something students occasionally have a bit of difficulty with is debugging their code when they encounter a problem. And so that gave me this idea to do a short presentation on debugging Ruby code, specifically with a tool called Pry. This presentation is aimed at people just starting out learning Ruby. So most likely you'll be at some point in Launch School's course 101, the Programming Foundations course. And we do mention Pry in that course. So some of you may have already used it. For those of you who have, some of what we cover in this presentation may already be familiar. But hopefully there's also some aspects of debugging with Pry that you won't have come across before. So the idea for this presentation is to provide a basic introduction to debugging with Pry. Pry is a powerful tool with lots of features, especially when you add the Pry-byebug capabilities to it. And it will take far longer than we have in this session to fully explore these capabilities. So this is very much intended as an introduction to debugging with Pry. We're going to talk briefly about debugging from a conceptual level and then work through some practical examples of using Pry and debugging with Pry and Pry-byebug. So this presentation, we're going to take a look at debugging Ruby code with Pry. First of all, we'll explore exactly what we mean by debugging. Then we'll look at some general debugging steps that you can use when approaching a coding problem that has an error in it. Next, we'll move on to looking specifically at debugging with a tool called Pry. As we do that, we'll talk about specifically what Pry is and the fact that it's a REPL. Then we'll look at using Pry, some different features. And then the main focus of the presentation will be using Pry as a debugger, and that involves invoking Pry at runtime within a running program, a Ruby program. And within that, we'll look at accessing variables and how that's affected by scope. We'll move on to debugging within that environment, and finally stepping through code with Pry and Pry-byebug. Okay, so before we get into the practicalities of using Pry, let's zoom out a little and think about debugging at a more abstract level. First of all, let's think about what we actually mean by debugging. To answer this question, let's first of all clarify what we mean by a bug. So bugs are essentially human errors in code. So how do they get there? Well, if you wrote the code, then the bad news is that you put them there, because bugs are human errors. The good news is that if you made the errors, you're also able to fix them. The process of identifying and fixing these human errors is what we mean by debugging. So debugging is an important skill to learn. As a programmer, bugs are a fact of life, and you'll probably end up spending a lot of your time debugging. Not just your own code, but other people's code that you may not be familiar with. And in that case, solid debugging skills become doubly important. I think a lot of beginner programmers maybe have this idea that when I finish learning to code, I won't make any errors. My code will be perfect. And that's not the case. First of all, I guess you never really finish learning, especially these days. There's always new tools and new frameworks being developed. So there's always something new to learn and something new to make errors with and cause bugs with. And secondly, human error is a fact of life. However good or experienced developer you are, and however well you plan out your code, mistakes will happen, so bugs will happen. So given that bugs occur, even in relatively simple code, it's important to know how to deal with them when they do crop up. So how do we debug code? Well, so now we understand what debugging is, let's take a look at how we actually go about debugging a program or piece of code. If you Google how to debug code, your search will probably return lots of blog posts with titles like the 7 steps of debugging a coding problem or 10 steps to debug code. Well, I'm sure those blog posts are really informative and useful, and the steps outlined and them are probably very valid for the types of problems that they focus on. I'd like to take a broader view and simplify things to 3 basic steps. So step 1, identify the problem. So where exactly in the code does the problem occur? This is about tracking down the particular line of code or method invocation or variable assignment that is causing the problem. If the bug raises an exception, then the error message or stack trace that accompanies that can be useful here. If not, then you may require some more detective work. Second step is understanding the problem. So once you've identified or located the source of the problem, you need to clearly understand why this particular line or piece of code was causing a problem in the first place. This may involve looking at it in its surrounding context. Perhaps it deals with specific inputs and outputs or references to certain variables, or as part of some iterative process that may be an issue with. And the final step here is implement a solution. So this is where you change the code in order to eliminate the bug that was causing the issue. If you follow the first 2 steps and correctly identified the problem and clearly understood it, this part should hopefully be relatively easy. So the way that you approach these steps will depend a lot on the type of error that you're dealing with. Errors can be categorized in a lot of different ways. For example, you could think about calculation errors or control flow errors and so on. For the purposes of debugging, I like to think in terms of 2 very broad categories, syntax errors and logical errors. So what are syntax errors? So this is an error in the actual writing of code, such as a missing character or a misspelled keyword that stops the code from functioning. In other words, the code that you've written does not conform to the programming language that you're using. With a syntax error in Ruby, you get some help here. The Ruby interpreter is really helpful, will generally provide you with some useful information in the form of an error message when it comes across the error at runtime. So let's look at an example here. So I've got a very simple program. Assign this variable a to a Boolean, and then I've got a conditional that if a is true, which it is, then I want to output it's true. So let's try and run this code. Okay, and we can see I've got a number of errors here. I think about 3. So they'll refer to this line 6 here. So that's probably a good place to start in identifying our problems. So let's have a look at that. Line 6 is this puts it's true. And you probably already spotted the error here. It's probably a fairly obvious one. The syntax highlighting helps out. Most code editors these days come with like a syntax highlighting feature, which can be helpful in spotting these kinds of errors or preventing them in the first place. The error messages give a bit more context. The unexpected T identifier is this S here after the second apostrophe or quote mark. the unterminated string is this part, and because Ruby thinks this is a string, this is our missing keyword end as well. It doesn't identify this as a keyword end. So if we didn't spot this error straight away, we might be able to do some more debugging here. So the couple of possible fixes here, we could use double quote marks here, or we could just escape this character, which is what we're going to do. And if we run our code now, it should just run without an error. So there are some basic steps there of identifying the problem, understanding it, and implementing a solution. And that was a fairly straightforward example. So they generally stop your code from running, but you get helpful error messages. Logical errors are a little different. With this type of error, the code will generally run without throwing an exception. But what happens is the code doesn't produce the results that it should or that you're expecting. So these are basically errors in the logic of your code rather than some sort of error in the language or syntax. The code generally runs but produces unexpected results. So given that they don't raise an exception, these types of errors are usually harder to debug. And this is where you need to put your detective hat on and really dig into your code and try to identify, understand, and resolve the problem. In so doing, you need to use all the tools at your disposal. And it's with this type of error that we're going to focus on today when we look at examples of using Pry. So let's look at another example here. So this is a simple program. It's just asking, it's outputting the string value here, then asking for some user input, which it assigns this variable, and then based on a conditional, it outputs one of these three things. So let's try and run this and see what happens. Okay, so we get asked to pick option 1 or 2. Let's try 1. So it's saying it's an invalid option. Let's try again. Option 2. Again, invalid option. Option 3 should be an invalid option. That's an invalid option. So the third one's working okay, but the first two should be giving us different output. So the code's still running. So it's not a syntax error, but it's a logical error on a program. It's not doing what it should or what we expect it to do. So let's go back to our code here. Without a helpful error message to guide us, we need to dig in a bit more here and do some investigating. Looking at our program, we can see that the required output is dependent on the user input because we're comparing it conditional. So we might think that the user input here is a good place to start our investigation. So a common and perfectly valid technique for debugging is to log input or log values. In Ruby, we can do something similar by using puts, so we can output values to the terminal. So let's output user inputs. So if we run our code again now, let's just clear the screen here. And let's pick 1 again. We can see that 1 was output, so we know that's the value that we're inputting, but it's still reading valid option. Let's try again with 2. Again, it's doing the same thing. So we know it's not a problem with the input. So that puts isn't really giving us much useful information. We're inputting 1, we can see that that's what's being assigned to user input. So something else we could do here is use Pry. So if we replace this line here with binding.pry. So if I run this code now, I will get an error message once I input. When it reaches that line, it's saying that there's an undefined method Pry, and that's because to use Pry, I need to require require it in my program file. So let's do that. Now I run it, I'll input again. And then when it reaches this binding.pry line, a pry session is invoked. And that's what we see here. This basically stops the program execution at this point of binding.pry, and then gives us access to that program in this pry session. It does a few other things, gives us some context. So we've got this this context here telling us where the file is, the file path, and it shows us where it stops the execution at this line here, and it gives us a few lines above and a few lines below. At this point, we might already have spotted our issue, but we can do a few other things here. We can access variables, so I can see what user input is, and we can see here that the syntax highlighting is giving us some clues that this is a string and we're comparing it to integers. But even if we haven't spotted the problem here, we can do a few other things. Like, as well as accessing the variables, we can call methods on them. So we can, for example, compare it to our value. We can run it through our conditional, and we see that it's giving false. So this conditional isn't working for this user input. And since it's not equal to 1, we might think, well, what if it's more than 1? So let's try that. And this is giving us yet another clue. It's saying that comparison of string with 1 is failed. So again, it's pointing to the fact that this is a string. And just to confirm that, we can call the class method on it. And we see, in fact, that it is string. So now that we know what the problem is here, let's exit. It should be a simple case to fix this. We could either call to_i here on user input, or we could actually compare to strings. So let's do that. Let's comment out our binding.pry and try running the program again. 1. You picked option 1. Let's try it with 2. You picked option 2. And 3 invalid option. So our program is now working as we expect it to. So that's a fairly basic example of debugging a coding problem with Pry. If you've never used Pry before, what we did just then might have seemed a little bit confusing. First of all, we were running our program in the terminal. Then suddenly we were in this other environment within our terminal window where we could access parts of our program and play around with them. That's a little strange. So what exactly was happening there and how? It might be useful here to take a step back at this point and ask a more high-level question, which is, what is Pry? Okay, so first of all, Pry is a Ruby gem. That means that in order to use it, you have to install it on your system. So the way you do that is gem install Pry. I already have it installed, so I'm not gonna run this. And then, as we showed, you also have to require it in your program file if you want to use it, or include a binding.pry in that file. Pry is also a REPL. So what do we mean by a REPL? So REPL is a read, evaluate, and print loop. It's basically an interactive environment that takes user input, evaluates the inputs, returns the results to the user, and then loops back to the start. So let's look at an example of what we mean by this. So this program here could be thought of as a very simple REPL. This gets part here is the read part of our REPL acronym. Hopefully you should all be familiar with this gets method and have used it numerous times. The this eval method you might not have come across before. This basically evaluates string elements as Ruby expressions in string. I'll just show a quick example of that actually. If I hop into IRB, eval, and then I'll pass it a string, say 2 plus 2, and I get 4. So this has actually been evaluated as Ruby code, what's in the string here. This P is the print part of our REPL acronym. Again, you should be fairly familiar with this method. And the whole thing is wrapped in a loop, so it'll allow us to put in input, then it'll give us output, and then we can put more input. So let's just run this and see what it looks like. So we can put in, say, like 2 plus 2, this is 4. Let's try 3 times 3. Outputs hello, and gives us the return value of 0. We can exit that. So if this seems familiar, then that's probably because on a basic level, this is pretty much how IRB functions. If you're in or have completed course 101, you should all be pretty familiar with IRB by now. So let's just jump into IRB and do the same sort of thing. So 2 plus 2 gives us 4, 3 times 3, and we can put hello. Again, it gives us the output and the return value. So that's a pretty similar thing. As you can see, there's some nicely styled prompts and line numbers, which you don't get in our homemade REPL, but it pretty much does the same thing. So Pry is at a basic level another REPL and can be used just like IRB. So to access Pry, you would just type in the Pry command, just like you would with IRB, and we can do the same things here. Just quickly run through them. So that's pretty similar. Everything we've done so far on our 3 kind of REPL examples all kind of does the same thing. However, Pry is much more powerful and has many more useful features than IRB. In fact, just from our simple example there, let's go back and do that again. You may have noticed that in Pry we get some nice syntax highlighting. We got our strings in red and our integers in blue and so on. So that's quite a nice feature already. Another interesting feature in Pry is the ability to change scope. So we can do this using the cd command. If you've read Launch School's Introduction to Command Line book, you may have already come across a command called cd that you use in your terminal, and that's used to change from one directory to another. In Pry, cd is used in a similar way, but instead of changing directories, it can move into and out of objects. So let's have a look at that. So I'm just going to create an array here. And if I cd into my array, you can see that the prompt has changed. That tells me I'm now in my array rather than the main scope here. And now I'm in there, there's some different things I can do. There's a method called ls, which kind of tells me some information about the context, that in this case lists different methods that are available to my array object. I can even call some of those methods directly. So let's have a look at what we've got. A method called first here. So I've called that here in this context. It gives me a 1, which is the first element of our array. Let's try last. That's the 3. How about reverse? Okay, so that gives us the array in reverse. That's quite neat. If I want to know a bit more about some of these methods, I can use pry show doc command. So let's pick a method here, let's say map, and this gives us a little bit of information about a map with some examples. So that's quite a nice feature in Pry already, which means that you might want to use it instead of RB just as a simple REPL. The CD command, you can change back out of this context by just using the 2 dots here to go back into our main scope. You can switch between the last 2 contexts using this minus flag, and then you can switch back to the top level scope at any time by using the /. So there's some quite cool features, but the real kind of amazing feature of Pry, I think, is what happens when you invoke it at runtime. So let's just recap that. So these other features that we went through. So invoking Pry at runtime, this is what gives it a real edge, I think, over something like RB. In our early example, we looked at using binding.pry in our program to interrupt the program execution and invoke a Pry session. At that time, though, we didn't really explain what binding Pry is. So there's actually 2 parts to this. There's the binding. So what's a binding? A binding is something that contains references to any variables that are in scope at the point where it was created. This is quite a complex concept, actually. If you're on course 130, you'll probably have some understanding of the concept of bindings. If you're not at that point yet in the curriculum, don't worry too much what this means for now. Just think of it as we're creating something that's pointing in the program that contains references to any variables that are in scope at the point when it was created. We can perhaps think of it as the state of the program at that point in its execution. If that seems a bit confusing, I'll try and clarify with some examples in just a moment. So the second part of this binding Pry is the Pry part. So Pry interrupts the program execution and pries open the binding so that we can have a look around. So having the Pry gem installed allows us to call this Pry method on the binding, and we'll have a look at that now with some examples. So here I've already required Pry. I've got a binding Pry in here. So I'm just going to run this example. Let me just exit out of here. Okay, so this is interrupted our program execution at this point here and opened up a Pry session within our program. So we've got a number of different variables here. We've got this A, which is assigned to 1, B assigned to 2, and C assigned to 3. So we can access variable A, that gives us the value of 1. B, again, this gives us the value of 2. What about C? What happens if we try and access C? So interestingly, that returns nil, which is a little strange. You might expect that to give some sort of error and say that it's an unknown variable. But that's not the case. It recognizes the variable and has access to it, but it doesn't know its value. The reason for this is there's some hoisting behavior going on here. We won't go into exactly what hoisting means in this session. It's a topic all of its own, really. If you've already got some experience of programming with a language like JavaScript, then you'll be familiar with this concept. If not, just think of it as the binding having access to variables that are in its scope on lines below it, but not having access to the variable assignments that come below it. This is quite important to remember when deciding where in your program to put your binding Pry, which we'll look at a bit later on. So something we just mentioned there is scope, and that's also an important idea when looking at placement of binding Pry. So we'll look at another example here. Here we've got a method defined, my method, with a binding pry within the method, and we've got some variables within it and some variables outside of it. So let's run this example. Okay, again, it's interrupted our program execution at the point where we put the binding pry. It's giving us a helpful arrow there. So let's try and access some of these variables. Again, A, that should give us 1. B, that gives us nil because although it can access the variable, it can't access the assignment at 2. And then our other variable was C, and that gives us the name error because it's outside of the scope of the method. So the binding cannot access this C, which is down here in this outside of the method. So scope is important in deciding placement. Another thing that's important in deciding placement is the actual functioning of your program. Like here, for example, you may wonder why we didn't just put it at the bottom of our method so we could access the value of B as well. If this was in a program, this would actually affect the running of our program. So here we've got a simple program that maps array values using this double num method. So it passes the block parameter to the double num method and then returns that to map, assigns it to this array, and then we'll print that out. So let's just run that program. Okay, we get 246 back. So you can see that's working. There isn't an error in this program. There's no bugs. But if there were and we wanted to debug it, we might think about putting a binding pry here. Now, if we do that on our program and then exit, we get an array of nils. That's because this binding pry method calling on binding returns nil. It'd be a similar case if we put a binding pry here at the bottom of our method. So at the bottom of the method or at the bottom of a block is, you might want to put a binding pry there just for debugging purposes, but it's important to remember that it might affect the output of your program as well. So one thing that we did there was we saw that we had like 3 instances of pry going on. And that's because we placed our binding pry in a loop. And when we called the exit command, this exited the instance of pry that was being invoked on each loop. And then when our program hit this binding pry on the following iteration, it created a new binding and invoked a new instance of pry. Let's have a look at another looping example here. So here we've got a simple loop. We've got 2 variables. First, they start off being assigned to 0, and then we increment both of them within our loop, and we've got a binding pry in between them, and then we break if our B variable gets equal to or greater than 3. So let's run that. Okay, so again, we can access our A variable as 1. B is still 0 at this point because it can access the variable, but it can't access the assignment. So let's exit. Then we get another instance of pry. A at this point is 2. And B is 1 because that's the value that was assigned on the previous iteration. And then it's the same thing the third time round. A is 3, and B should be 2. Okay, so pry is really useful for debugging code that contains looping structures. And we'll work through another example shortly. But before we do that, I just want to show you one more tip for navigating the environment in Pry. We've seen a few examples of an instance of Pry being invoked. When this happens, you're showing some context in terms of where the binding Pry is in your code and a few lines above and below that point. The reason for this is because when the Pry instance is invoked, a command called where am I is automatically executed. However, we can execute that command at any time. So say, for example, I've cleared my screen. In fact, let's go back to the previous example. Say, for example, I've cleared my screen here, and I want to get back to my context. I can just call where am I, and it brings it back. It shows me where I am within the program. Another thing you can do is pass a value to where am I. So let's look at another example. So by default, it shows you the point where you are in the program and 5 lines above and 5 lines below. But if I wanted to see a bit more context on that, I could pass an argument to where am I, say 15, and we see 15, if there are 15 lines above and 15 lines below. So that's quite useful in giving some context. Okay, so now that we've looked at some of Pry's features and explored what a binding Pry is, let's work through a couple of examples of debugging. As mentioned earlier, Pry is very useful for trying to debug code that contains iterative or looping logic, since it allows us to interrupt the program on each iteration and see what's happening in our program step by step. So let's look at a problem. Okay, so here we have a problem where we want to take an array and run some kind of filter on it to return a new array. So the problem description says, write a method that, given an array of integers, returns a new array containing only odd numbers that are less than or equal to 15 or multiples of 3. Okay, so we have this solution coded up, and we have a few test cases down here. So when we first run our program, let me just exit out of this Pry session. I think it's 9. Okay, so of our 3 test cases, 2 of them fail, so return false, and the third one passes. So let's focus on the first 2. We can comment this third one out. And if one trying to solve this, one of the things we can do is maybe go to our earlier idea where we're looking at using puts to try and output some value. I guess what we could do maybe is copy part of line 13. We might think this is where the problem is. This is the main bulk of our code. So we could copy this and output this to our screen and help us see what's happening. So that doesn't really help us very much at all. We could maybe comment this out and then comment out this part of the test case. And that's a bit more helpful. We could perhaps kind of look at these values and try and relate them to the different elements in our array, but it's still quite hard to reason with this code in this context. It's hard to see what's going on at each iteration. So this is where we can use Pry instead. Let's bring these back in. So instead of using a puts here, we can add a binding Pry. Let's just clear the screen there. And now if we run our code again, so when Ruby hits that binding Pry, it's going to stop execution of our code and show us where we are. So we're at this line here. And as with before, we can kind of play around and access some variables within this context. So we can kind of see what new R is. At this point, it should just be an empty array. We can see what num is on this iteration. which is 1. Let's have a look at the array that was passed in. So that's the first element of our array. So we know we're on the first iteration. We can call some other methods. So we can look at our conditional here, which should push this value of num into our new array if these conditions are met. So we can test to see if num is odd, and that's true. So we can test to see if num is less than 15. Okay. And that's true as well. So we kind of know that this number should be pushed into this new array. So we can exit and go to the next iteration. And then if we check new array here, we would expect it to contain 1, which it does. So far, we haven't really spotted any problems. Let's clear our screen and try again. Sorry, spell that. Okay, so we're now on a second iteration. So let's look at what num is. So we're now 2, which is the second element in our array, as we can see here. So we can do some things here. We know that 2 shouldn't be odd, but let's just check anyway. So that's false. So you know that this part of our conditional isn't going to run. Let's see if we divide it, what the remainder 3 equals 0 or not. That returns false. So we kind of know that this shouldn't be pushed through to our new array. And let's go to the next iteration and then check new array. And in actual fact, it's only got 1 in. So far, our code seems to be working as it should. Let's try again. Let's just see our context again. Okay, let's see what num is here. Num is 5, which is the third element in our array. So 5 is also, we'd expect this to return true. Again, this should be added to our array. It doesn't look like we've come across a problem so far. Okay, new R now has 1 and 5 in it. So far, our code is functioning as we would expect it to. What about the next value? So number 6. Okay, so let's see what happens. That shouldn't be odd, so let's just double check that. That's false. If we divide it by 3, so or remain 3 rather, then that should return true. So we would expect 6 to be pushed into our new array. If we check new R now, it's there, right? So what's the issue here? So let's have a look at a bit more of our context. And here, if we look at the test case for this first test, there isn't a 6 in the array we're comparing to. So that's a little strange. Like the way we've written our code, the 6 should be added, but it's not in our test case. So we've got kind of an issue here with our understanding of the problem. And if you go back to our problem description, it's not really that clear. So it's saying write a method that, given an array of integers, returns a new array containing only odd numbers that are less than or equal to 15 or multiples of 3. So that could be read in a couple of different ways. It could be read that the only odd numbers that are less than or equal to 15 or multiples of 3, or only odd numbers that are less than 15 or multiples of 3. And that's the way we've actually coded it here. But we've kind of misinterpreted the meaning of this problem description. And our test cases confirm that, because the way the test cases are written, you can see they're only odd numbers. So we should only be pushing odd numbers to our new array. So working through code in this way using Pry is not useful only for debugging. It's useful also to clarify problem requirements and problem descriptions that may not be completely clear to start off with. So now that we've understood our problem a little bit better, we can fix this. If we go back to our code, we can see there's a precedence issue here. So we can fix these by putting parentheses around this part of our code. Let's comment out this binding.pry. Exit. Now if we run our code again, yeah, we had our last test as well. So all our tests should return true. So that's an example of debugging kind of looping code with Pry. So running that previous solution with Pry was fairly straightforward, since there are only a few lines of code. If you have more complex code with multiple lines that you want to evaluate, it would be really useful to be able to step through the code line by line rather than just being at the point where we added the binding.pry. Although you can't do that with Pry itself, there's another Ruby gem called Pry-byebug, and this extends Pry by adding some further commands, such as those that let you step through code. Pry-byebug extends the capabilities of Pry by adding commands such as next, step, and continue. So let's just have a look at these. So we've been through that. So extends Pry additional commands next, step, and continue. So we'll look at that with an example. There are other gems similar to Pry-byebug, such as Pry-nav and Pry-debugger. So they pretty much do the same thing. I think there may be some slight differences, but we're going to be looking at Pry-byebug here. Let's take an example here. Okay, so this is a solution to quite a classic coding problem called FizzBuzz. Some of you may have heard of or even solved this problem. For those that haven't, the general idea here is to transform some values according to rules as defined in the description. So the description says, write a method that takes as an argument an array of integers and returns a new array with the integers transformed. If the integer is divisible by 3, it should be replaced with biz. If it's divisible by 5, it should be replaced with buzz. And if divisible by both 3 and 5, it should be replaced with bizbuzz. If divisible by neither 3 or 5, the number should remain as is. Okay, so we think we understood those problem requirements, and there's a test case here with an example output. So we could try just debugging this with Pry, but the question of where we would put our binding.pry, we could put it here and then manually run through all of these conditions like we did in our last example, or we could think about maybe putting Pry in each of our multipliers, like one in each of our conditional branches. That could maybe get a little bit confusing. So instead, we're going to use Pry-byebug. You can see that I've already required it here. You also need to require it, and you also need to install Pry-byebug as another gem. So if you haven't got that installed in your system, you need to install it the same way we would do Pry. So let's take a look at running through this code with Pry-byebug. Okay, so again, our program execution is interrupted here. At this point here, the first branch, the if condition for FizzBuzz. So here we can use next to run to the next line. And you can see that our position drops down to this else if branch because this condition didn't pass. If we look at num, we'll see that's 1, so that makes sense. We wouldn't expect it to, it's not divisible by 5, it's not divisible by 3 either, so if we go next again, we can see it drops to the the next else if branch. Let's just clear that. And next again, it drops this else branch down here, which just returns the number is which we would expect with num, because it's not divisible by 3 or 5. So let's go next again, and we return back to the top here. This binding.pry, and let's see what num is on this iteration. It's 3. Okay, so next again, and we drop to the first branch in our conditional. If we next again, we drop to the second branch because 3 isn't divisible by 5, or so both of these would fail. So let's next again, and we would expect this branch to pass our fifth branch because 3 is divisible by 3. So if we next again, yeah, so we can see that it's dropped into this branch. And then we go back to the top, and we've got a new number, which is 5. It doesn't pass the first branch, so it should go to the second. On this occasion, it should drop into that branch, which you can see here. So our buzz condition is met. And on the fourth iteration, our number here is 6. So we would expect this to not pass the first 2. But the third one, it should on the next go drop into this branch, but it hasn't. It's gone down through our else condition here. So there's an issue here. 6 should be divisible by 3, so we can see that the issue is with this else if branch num equals 3, and we've incorrectly formulated our condition here. So that's what the problem is. Currently, it's only testing that num is equal to 3, and not that the remainder 3 is equal to 0. So we can fix that. Let's remove our binding.pry here. And now our test case is passing. So that's an example of stepping over code using the next command. We'll look at another example now of stepping into code. So here we can see that we have kind of another looping iterative solution. We're mapping numbers in an array based on whether they're even numbers or not. If they are even, then we call this helper method called double num. So let's have a look at how we would work with that in Pry. Okay, so it's returning false. There's an error with our code. So let's put a binding.pry in here, just inside our block. Try and run our code again. So here we can see that we've interrupted program execution at this line. We can see what num is here, which is 1. So that's not even, so it should return the second expression. So let's go next. That sends to Pry. Num here is 2, so that is even, so that should call this double num helper method. So we can call that and pass in num, which is 2, and that returns false. So that seems to be working correctly. So here we can say next again. None here, still 2. Next. So none is 3 here, so that's an even number. So we can probably just use continue here to move to the next iteration. And num here is 4, so that's an even number. So this should call our helper method. So at this point, let's try calling that. And we get 6 back, which is a little strange because we would expect if we were doubling this value of num4, we should get 8. So here we can actually step into our method. Let me go back. Right, sorry about this. That hasn't worked quite as expected. Let me just start again. So you can continue to go to the next iteration. Num is 4. Okay. So we should be able to, yeah, so, so we can step into this method rather than stepping over it. And by doing that, we can see that the issue is here on line 12, that this should be num times 2 instead of num plus 2. So having identified that, we can go back to our code file and we can fix that. And now if you run our code, it's running true, so our test is passing. So that's a little bit about, sorry, let me just go back. Stepping through code. This concept of stepping through and into code is not limited to prior Ruby. So there's equivalents in other languages. For example, in Python, I think there's an equivalent called IPDB, and in the Chrome DevTools, there's a debugger that works in very much the same way. So just to quickly demonstrate that, I've replicated the last example in JavaScript. So this is our example again, and it works very much in the same way. This is Chrome's debugger tools. Rather than putting a binding.pry, we can do what's called creating a breakpoint. But it runs very much the same way. It interrupts program execution at this point. We can access variables. And let me just go to the next iteration. So num's 1 there, as we can see. We can step over code. And we can see variables being output. 2, we can call methods in the same way. And get a return. And we can step into code in the same way. This moves up to this line. So that's just a quick demonstration, just to show that this concept isn't limited to Pry or Ruby tools. It's something that you use in a lot of different environments and different programming languages. Okay, so that's pretty much it for the presentation today. Just a few points to wrap up. Just to emphasize here, debugging is a really important skill to learn and practice. I really can't emphasize enough. It's something that every developer should be familiar with. You don't have to use tools like Pry in order to debug Ruby code. However, they can make debugging a lot easier. I also think that using these tools to really dig into a problem at the code level helps improve your understanding about how programming languages work. And also, learning how to use a tool like Pry is useful, But don't just focus on a particular tool. The concepts such as instructing program execution, accessing variables and methods or functions, and stepping over or into code are transferable to other programming languages, for example, as we've just seen, JavaScript. So that's pretty much it. Thank you all for attending. I hope you found the presentation all interesting and useful.